Welcome all. My name is Prateek. Uh, I work for Emirates Airlines in Dubai as a pen tester. So today I'm going to take a workshop on iOS application pen testing with Egor, who's my colleague. Uh, so before that, I would like to give you a small background of what I do, what I've done in iOS pen testing. So I have made a small application. I don't know if you've heard the name of this or not, but it's called Damn Vulnerable iOS Application. That's me. That's not the phone. Yeah. So yeah. So this is the application that I created. It's basically a vulnerable application. I have basically included all the possible vulnerabilities that usually happen in iOS applications. So some regular guy can just test it, use it as a practice for pen testing iOS applications. On the left side, you can see all the different vulnerabilities. If you go here, you can basically read a list of all the articles that I've written for free. So there are like 43 articles, which starts with the very basics, starting with how to set up a mobile pen testing platform, and then we can move on to more advanced topics. Um, we have added all the different vulnerabilities that you basically find in iOS applications, like insecure local data storage, jailbreak detection, uh, uh, vulnerabilities related to extensions, and everything, runtime manipulation, sensitive information in memory, and all that. Okay. So I would definitely recommend that you download this application. To download this application, you need to have a jailbroken device because Apple doesn't accept this application because it's full of vulnerabilities. So I would recommend you check it out. Um, Also, if you don't know how to solve the challenges, the solutions are also available for free. So, but I would recommend you give it a good shot before you actually download the solutions. Okay. So, yeah. So this is the application, and most of our talk today is going to be based on this application. We're going to show you demos of this application, and then show you how these vulnerabilities apply in real life. Okay. Okay. So as you can see, as I said earlier, my colleague Igor is here. He'll also be taking some part of the presentation. He also contributed a lot to this application. So yeah. He'll give his own introduction when he comes. So this is the agenda that we have today. We'll start with introduction to iOS applications. Basically, what are iOS applications? How you build iOS applications. We'll understand how to set up a pen testing platform for an iOS application. Then we'll look into Objective-C runtime, and then we'll move on to different vulnerabilities like insecure data storage, URL schemes, and analyzing traffic over HTTP, HTTPS, jailbreak detection, and all that. Okay, and then finally we'll discuss secure coding guidelines. Okay, so what are iOS applications? So iOS application is nothing but the application that download from the App Store. Okay, they are distributed at .ipa files. So any application that you see that has the extension .ipa is an iOS application. Basically, it's nothing but the application bundle compressed as a zip file and then renamed as .ipa. So you can basically, if you just remove the extension .ipa with .zip and then you uncompress it, you will see the bundle of the application. We'll go into that in later detail. These are compiled for ARM architecture. Now, ARM architecture is what you usually see in embedded devices for Android and also for mobile applications like Android applications and iOS applications. All of them are built on ARM architecture. This is different for the regular x86 architecture and x64 that you have in desktop applications. Even in ARM, there are like different architectures. There is ARM-V, ARM-V7, ARM-V7S, ARM-V64. Recently, Apple moved to 64-bit architecture, so now they're using ARM-V64. Uh, to build an application as a developer, you need a provisioning profile. Okay. Now, why do you need this provisioning profile? This is because Apple only allows applications that are signed by a trusted certificate to run on the device. So all the applications that you download from the App Store, they're signed by Apple and verified before they're put into the App Store. If you're a developer and you want to run the application on a device, you need to purchase a Apple developer program. What they do is that they give you a certificate and a provisioning profile. This trusted certificate can let you run your applications on your device. Okay. And obviously, all the Apple applications that are there on the App Store are encrypted. Okay, so we'll look in later how to decrypt them. Okay. So there are basically three kinds of iOS applications. One are the native applications, which are basically developed in Apple's own language, Objective-C. These deliver much better performance because since they're native code, they can use all the native functionalities like camera and like audio recording and all that. Then there is web applications. Web applications are nothing but a wrapper. It's like a web application that is optimized for mobile. So it's developed in HTML, CSS, and JavaScript. And then you have hybrid applications, which are developed in web and native applications. So the advantage with using native applications is that it delivers better performance, okay? But the advantage of using web applications is that you don't have to regularly update your app because since it's downloading the content from the web server, you can just update the server-side code and you can show it in the app. Some of them, mostly people use hybrid applications, which is a combination of both. So you can use native features as well as the advantage of updating your content in a web view. So the web applications, they run in iOS own browser, which is the WebKit, inside a UI web view. Okay, so that's the Apple's own implementation of a mobile browser. Okay, so I'll explain you all of this when we look into Xcode. So I'll just like to give a brief description of Objective-C. So most of the native applications for iOS are built in Objective-C. The advantage of Objective-C is that it's an object-oriented programming language. It's basically a superset of C, but you add object-oriented capabilities. Okay, it's the main programming language used by Apple for making iOS and OS X applications. Okay. So just like to give you a brief introduction of the syntax that is used in Objective-C. As you can see, it's pretty much different from what you see if you're coming from a background of Python or Java. This is really different. So that's how you allocate an object. So first of all, every object in Objective-C is a pointer. Okay, so every object is a pointer. So this is how you initialize an object, which my object O, my object allocate init, allocates the space for it, and init initializes it. Now, you can also initialize with a particular parameter. In this case, I'm initializing it with a string. Or you can initialize with different objects as well. So this is creating an array with 3 different objects. Okay. Now, the good thing about Objective-C is that even though it's tough to write, but it's very easy to understand. So you can easily see here, it's creating an array, and it's creating an array with 3 objects. So these objects form a part of the array. Even this, it's pretty easy to understand. You're basically performing some task. Obviously, if it's a real application code, the task will be mentioned. Perform task with ID. So it's really easy to understand. It's very verbose compared to Python or some other language. Okay. The other thing about Objective-C is that every class has 2 files. One is the extension, which has .h extension, and the other is with .m extension. Okay. And there are basically 2 different kinds of methods for every class. One is a class method and one is an instance method. The class method always starts with a plus, whereas the instance method starts with a negative. Okay. So if I see a plus, it means it's a class method. Whereas if I see a negative, it means an instance method. Okay. So now we're just gonna build a simple application, a simple hello world application. So I can just give you a brief introduction of like how you make applications in Xcode. Okay, so I'm going to open up Xcode. So once you start Xcode, you get something like this. I'm going to create a new project. And I'm going to choose, there are different kinds of formats you can choose. I'm going to choose a single view application. And I'm going to name it Hello World. Save it. So once you initialize an application, this is what you get. You have the app delegate class. Now, what app delegate is that it's a class that basically handles a lot of the events that happen in an iOS application. So assuming you are holding an application and you press the home button, you go in the background. In this case, this method will be called. Okay, application did enter background. As you can again see, it's very easy to understand what's going on. Application did enter background. So obviously this method handles the case when an application enters the background. So you can write your own code here. Similarly, application did finish launching with options. You can, this is the method that gets called when an application launches, okay? Uh, Here you have the storyboard where you can see what, what you will see visually in an application, okay? So now I'm just gonna add a simple label to this application, and I'm just gonna name it Hello World. And now you can run the application and it will launch the simulator. And this is it. Okay, so this is how you create a simple iOS application. Uh, Another thing I wanted to mention is view controller. Now, what view controller is basically, so think of view controller as every view controller as a different screen. Okay, so this what you see here is a view controller, and whatever methods you will add for this particular screen will go inside this view controller. Okay, so whenever you see the word view controller, it means a different screen. Okay, so remember this point because we're going to use this. Okay, back to the slides. Okay, so another Apple in 2014 they added another language, Swift. It's basically a more Python-like language with very less code, like things that will take 50 characters in Objective-C will only take 10 characters in Swift. It's like it's not that verbose, but it's a brand new language. Language is still in, it still has a lot of bugs. It's still not being adopted completely for building iOS applications, but yeah, this language is there. Okay. The other thing about Swift is that instead of using Objective-C, basically it's a runtime language. Okay, whereas Swift is a compile time language. So instead of what Objective-C does is that it defers most of the decisions during the runtime. So what methods are being called, the mapping from methods to the actual pointers are decided at runtime, whereas in Swift those are decided at compile time. We'll discuss this later when we get to the actual vulnerabilities. Okay. And another thing, the symbols. So if you don't know what is symbols, symbols are basically like content added to the binary file so that it's easier to debug. Okay. So Swift has symbols like this, which is very complex to understand, but every character here has a specific meaning. So T can stand for like all of them, T, F, C, 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 4, they have different meanings. It could be, for example, if this is a function, it could be the return type or the kind of function it is, if it's an instance method or class method. So everything, of all these things have different meanings. Again, we'll discuss this later. So now I would like to, so now let's get to actual pen testing. So what do you need to actually set up a pen testing environment? Okay. So first of all, you need a jailbroken iOS device. This is a very important thing because if you don't have a jailbroken device, you can basically do nothing. Okay. Because you need to run all the tools that are there for analyzing applications with root privileges. And if you don't have a jailbroken iOS device, you don't have root privileges. Okay. So this is very important. Secondly, if you want to do code reviews and all, you should have Xcode installed on your system. Okay. And then you need to install all the pen testing tools on a jailbroken device for pen testing. Okay. So how do you jailbreak a device? There are free sites for jailbreaking a device. I would recommend, if you're running up to iOS 8.1, you can use pango.io to jailbreak a device. And it's really very simple. You just get a screen like this, and you get your connect your device to the computer, and you just click on start jailbreak. That's it, and it will jailbreak a device. Okay. Now for iOS 8.2 and 8.3, there are semi jailbreaks available that you can go to this website, Pango 8. And after once you're done with pen test jailbreaking your device, you need to install all these tools. You need to install an SSH server so you can connect to your device with using SSH. Then you can install all these tools, ClassDrum, Cycrypt. We will look into each of these tools one by one. Okay, so now I'm just going to show you my device and prove it to you that it's actually jailbroken. So I'm going to go to my device. Okay. It's a problem. Okay. Okay. So once you jailbreak a device, one application gets installed by default. Okay. The application name is Cydia. Okay. So what Cydia is basically an app store for jailbroken devices. Okay. So if you jailbreak a device, so if you are using a regular iPhone, you basically download applications from the app store, right? Now, if you jailbreak a device, you can download applications from Cydia. Uh, Cydia you can install all the tools that you usually use for pen testing. For example, you can download Python on your device, okay, and you can run Python code. You can download OTool, which is again a very popular tool, and this basically comes in a package called Big Boss Recommended Tools. So this is something that you download from the very start. Big Boss Recommended Tools. It has basically all the necessary binaries that you need for pen testing an application. So as you can see, I have all the important tools installed. I have Cycrypt already installed. Okay, you basically click here and you click on install to install these applications, and then you can just SSH into this device and run it. Okay, so if you want to look at all the packages that are installed, you can go to the install section and go here. As you can see, I have a lot of tools installed. So make sure you install all these things once you jailbreak your device, and then you can actually get started with pen testing. Okay. So yeah, let's move on to the slides. So again, what does an iOS application look like? As I told you, it's just a compressed zip file. Okay. So once an iOS application installs on your device, it looks something like this. There is a data container. There is a bundle container. Now the bundle container contains the application binary and the images, like the resources that were used to build the application. The data container will contain all the data, like all the data that is saved locally on the application. And then there is an iCloud container if your application is using an iCloud. Okay. To explore your device, I would recommend you jailbreak a device and then install something like iExplorer or iFunbox. Okay. What this does is that it lets you explore the raw file system in your iPhone. Okay. So you can go browse to any folder and just look for the content. So let's go through a demo of iExplorer. So as you can see, okay. Yep. So this is my iPhone. Okay. Over here you can see all the apps that are installed in the iPhone. You can click on them and explore the content inside it. So I'm basically looking into all the content that is inside the application. So you can see the cookies that is storing and all the caches, all the files inside it. If you find anything that is like a password or something in this, then it's a vulnerability, because to explore this thing, you don't even need to jailbreak a device. Okay, so remember that. And these are all the applications. Again, I would like to show you another tool, which is iFunbox. This is another file explorer utility. Here you can actually go and explore the raw file system. So now this is my root directory. I can go to where, so I can, if I want to see all the applications, I can go to where mobile, containers, and bundle. Bundle will contain all the bundle, where data will contain all the data. So if you want to look at the data, you'll go to data, and then you'll go to application. And then these are all the applications that are installed. Now you can see different IDs, like different random numbers. So I don't know why Apple did this, but basically these are all the applications that are installed on a device. Okay. So we will later find out how to find out the application name by looking at the ID. And if you go inside this is a particular application, and you can see, as you can see, this is the Citrix application. And then you can see all the data that is storing. This looks like a receipt. So you might want to copy this to a Mac and then like analyze it for more details. Okay. Yeah. So another thing I want to tell you is that you need to know the location where these applications are actually stored in your device, because your iPhone is like just like a stripped down version of a Linux system. So you should know where to look for, right? So in iOS 7, if you're running an iOS 7 jailbreak, this is the location for a mobile applications. It goes inside where and then the user mobile and applications. All the applications that are installed by App Store by default on iPhone. So once you buy your iPhone, what are the applications that are installed? You have the camera application, you have the messages application. They will not go inside where mobile applications. They will go inside slash applications because they need root user privileges to run. Even in phone application, that will go inside slash applications. Okay, whereas the mobile application, like the application that you download from the App Store, will go inside this folder. Okay. Uh, Another thing is that every application, now this is a security feature implemented by Apple, is that every application runs inside its own environment, which is called the application sandbox. Okay, this is done so that one application cannot access data from other applications. So every application is working inside a closed container, which we call the application sandbox. Okay. Now for iOS 8, the location for applications is different. The application go inside slash var mobile containers bundle and application. Okay, so let's quickly look at that after the slide. And the downloaded applications will go inside this folder where the downloaded bundle data will go inside slash data. The only difference between these two URLs is that here it is bundle, okay, and here it is data. So that is the only difference. Okay, so now let's go SSH into the device. So I'm going to SSH into my local device. Okay, so now I'm inside my iPhone. Okay, I can do NLS or PWD to see I'm inside the root folder right now. Now this is an iOS 8 jailbreak. So the application, first of all, let's look at the application that are installed by Apple. Okay, so I'll go inside slash applications to look for all the applications that are installed as the root user, and I can see all these applications. Okay, cameras, compass, and all this calculator. Okay, you can just go inside any application folder and look inside the contents. Okay, now this is the application binary. The application binary will have the same name as the application. What you can do is that you can download this application binary to your device and then start disassembling the application and look for, you can disassemble to look at the code, try to figure out what is the code there. Or you can look for hard-coded strings or encryption keys and all that. We'll look into this in this workshop as well. So let's go back. And now let's go to slash var mobile applications. Wait. Container. Okay, so now let's go inside the bundle. Okay, and application. Now these are all the applications that are installed from the App Store. Okay, I will give you the slides, so you don't need to remember all the location, but this is where you should look for. Okay, and as you can see, they're like different IDs, and you don't know which ID is which is for what. So just press ls star. Okay, and it will give you the entire directory listing. In my case, I want to look for this application, damn vulnerable iOS app. So this is the ID for it. I'm gonna copy that, and I'm gonna browse to this directory. Okay, now I'm inside damn vulnerable iOS app. So now let's go inside this, and this is all the content. This is the application binary. I'm really interested in that because I want to reverse engineer it and look for certain important things that I want to look for. You can also reverse engineer it, particular methods, to actually find out the code for it. Let me actually show it to you right now because it's pretty cool. So I use a tool called Hopper. Okay, it's a disassembler for ARM and Mac binaries. Okay, so it's a really cool tool. I have a licensed version myself, but you can also do almost everything with a free version. The only difference between a licensed version and a free version is that in licensed version you can also modify the code. Okay, whereas in the free version you can only analyze the code. Okay, so I'm just gonna disassemble one application. I'm going to disassemble this application. This is the application binary. Okay, and as you can see, it only has one architecture, which is 64-bit because my iPhone is 64-bit. But by the way, one application can have different architectures as well, because if you download an application from the App Store, the App Store doesn't know whether you're downloading from a 32-bit device or a 64-bit device. So one application can have two different architectures. We call it fat binaries, okay, because it has different architectures combined into one single application. The only disadvantage of the fat binary is that it usually is twice or thrice the size of a normal application, because you have the same code basically for different architectures combined into a single executable. Okay, so now it starts analyzing this application. Over here you can see the progress bar, it's still analyzing. So we'll wait for it to finish. And all of these features are available with the free version as well. So I would definitely recommend you check this out. Okay. So while it analyzes, let's look for certain things that you can find out. Now imagine an application that is encrypting some data locally, okay, and it's storing the encryption key somewhere in the code. If that encryption key is stored in plain text in the code, it will appear as a string in the application binary. So here you can look for important strings. All these things are basically hard-coded strings, not hard-coded, but strings that the binary has, okay. So you can find, so whenever you're looking in an application, you can basically, look for things like encryption key or encryption salt and look for it, okay. Now another thing that you need to know is that Hopper by default, it decrypts the application before it analyzes it, okay. Later we'll see how to manually decrypt an application, but if it seeing some other random code while disassembling from some other application, remember that Hopper does it automatically, decryption, okay. Now over here in labels you can actually see the methods in the application, okay. Now let me again go to this application, okay. So one of the methods is in this application is a jailbreak test. Okay, it says the device is jailbroken. If as a hacker, I would like to make my app work even in a jailbroken device. Some banking applications, they add a check to make sure that the application that the device is running on is not jailbroken, because they don't want their applications to be analyzed on a jailbroken device. So they do a test to see if the device is jailbroken or not, and if the device is jailbroken, then they don't allow the app to run, they just quit, okay. So if I was interested in looking for this particular method that checks whether the device is jailbroken, I could go here inside inside labels, and I can go and just search for jailbroken, okay. And these are all the methods. So which method do you think checks for jailbroken device? I think it's this one, jailbroken device, jailbreak detection VC is jailbroken, okay. The other really cool thing about Hopper is that you can actually see a pseudo code for it. So it will disassemble this application. Okay, it cannot create, it cannot create code for 64-bit devices, but we'll solve this challenge in a 32-bit application as well. So we'll look that. Another thing that it shows is the control flow graph, okay. So here you can see where this code is going, the flow of this particular method. So assuming I want to jump instruction from here to some other location, I can just reverse this logic, which is compare. I can reverse this logic, and instead of 0, I can replace it by 1, and that will replace the reverse the flow. So if it was going here before, it will go here. You understand? This is the compare instruction that decides where this application flow will jump. So we'll look into that, but we'll look into Hopper in great detail in the coming hour, but just wanted to give you a brief intro. And this is how a typical application directory looks like. I just showed you. Okay. And Xcode we already discussed. Okay, so understanding the Objective-C runtime. Now, one of the major issues with Objective-C is that it's a runtime language. Okay. Now, what is a runtime language? It means that most of the decisions that it makes, it differs to the runtime rather than the compile time. So assuming there is a mapping for a particular method to the implementation, okay, method to implementation, that thing is found out during runtime. Now what vulnerability that makes is that you can hook into the application while it's running, and you can modify the method pointer to the implementation. You can point this method to point to somewhere else during while the application is running, and when the application runs that method, it looks for it at that particular time, And if you modify the implementation, it will look for that particular method, and you can actually change the implementation of that method. This is what we call runtime manipulation. Okay, just like you can switch methods, you can also switch different variables. Okay, so you can change different properties and variables during runtime. Okay, now this is the main issue. Messages aren't bound to method implementations until runtime, thereby allowing us to modify the method implementation. Okay, and these functions are implemented in this shared library that you can find using O2. Uh, Now we're going to look into another utility, which is class dump. Basically, what it does is that, assuming there is a application binary, you can extract the method information for that particular binary. Okay, what does that tell you? Assuming you get an application from the app store, okay, you can actually see all the methods and all the classes that are there in that application. Now this is huge. This is very useful information, because assuming you want to patch some method, by just looking at the method's name, you can know which method I want to patch. Okay, so to find out this class information, we use class dump z. So now we'll show you a demo of class dump. So I have this binary with me already on my desktop. Okay, I'm going to dump the class information for this particular binary. So what you just do is do class dump z and then give the binary name, and it will show you all the methods. Okay, now you can see just see the kind of amount of information you have. You have the class name. Okay, you have the property names, and you have the method names. Okay, this is very useful information when you're doing runtime manipulation, because assuming I want to, so this is a boolean method, right? What if I can change this method to always return true or false? I can look for this particular method and I can patch this method using runtime manipulation to always return true or false. But even to do a runtime manipulation, you must first know the method, right? And this is how you know it. This is how you know the name of the method. Another thing that I want to tell you is that class dump z will only work on decrypted binaries. Okay, it will not work on encrypted binaries. I'm already doing it on a decrypted binary, but right now I'll show you how to decrypt a binary. So for decrypting a binary, we use another tool called clutch. Let me go back to root. So the tool name is clutch. Okay, it's a really nice small utility that basically allows you to dump an application. Okay, like decrypt an application. So once you just use, you can see the user's instructions here. If you use the I, it will show you all the applications that are installed on a device. So I'm just gonna do clutch I, and it will show me all the applications that are installed. Okay, so what if I want to dump, like decrypt this GoPro application? I will copy this app ID for this application, and I will give it -d followed by the app ID, and now it will start decrypting this application. Oh. Okay. So now it's decrypting the application. As I told you, every application has different architectures. So it's decrypting for ARMv7 and ARMv7s. What this tells you is that this application was actually a FAT binary compiled for two different architectures. One was ARMv7 and the other was ARMv7s. Okay, so it tells me that the application was decrypted here. Okay, now this is the IPA application that is decrypted. Now you can just copy this IPA file to your desktop, and now you can run class dump against it. So it's now decrypted. It can show you the class information. Okay, like talking about FAT binaries, I will just like to give you a small demo of that as well. Now, why is FAT binaries important is because Apple recently moved to 64, like not recently, but it moved 1 year back to a 64-bit architecture. Some of your tools, they might not work against 64-bit applications. They might not work against a FAT binary. Okay, in that case, it's very important that you strip out the 64-bit part from an application binary. So if it's 32-bit or 64-bit, you can strip out the 64-bit, leave the 64-bit, and just have the 32-bit. Okay. Now, how do you find what is the architecture of a particular application? So for that, I use a very nice utility called LiPo, and you can just use LiPo -info and give it the application binary as the Can you see, by the way? Can you see properly? Is it visible in the back? Not so much? Oh, okay. Sorry. So you use this utility called lipo, and you give the hyphen info command followed by the application binary name. And once you run it, it will tell you what are the architectures. Okay. So this application has two architectures, ARMv7 and ARM64. Okay. Now using lipo only, you can using lipo you can actually strip out a particular architecture. I don't remember the syntax, but it's pretty straightforward. Okay, so you can just strip out this ARM64 architecture, and after that what you will get is just this ARMv7 architecture. You can also do it using a hopper. So once you patch an application in hopper, it will only patch it for one architecture. It will remove all the other architectures, and it will only give the final binary as the particular architecture that you patched. So assuming I give it a fat binary, I give it these two architectures, and I only want to modify 64-bit, it will modify the 64-bit logic, and it will generate a binary which is only 64-bit. Okay, so that's pretty awesome. Another thing that I would like to mention is that uh, okay, we'll look into this. We will do a complete demo of how you can take a binary, modify the logic, and then save the application, sign it using your own key, and then again deploy to the to the device, and then run the application. Another thing that I actually forgot to mention is that if you're changing the logic, like if you're patching an application, you always need to re-sign it, because Apple doesn't allow like unsigned applications to work on a jailbroken device. Okay. Now, if you have a regular iPhone which is not jailbroken, it will only allow those applications to run that are signed by Apple's own trusted signature. But in a jailbroken device, you can also run self-signed binaries. Like you can just sign it and you can run it. You can just self-sign it and run it. But the application needs to be signed. And if you modify the implementation of a particular method or anything, the application loses its signature. So make sure you sign this application before you deploy it to a device. Okay. So this is class dump demo. Applications that are installed by default won't be encrypted, I already mentioned, and hence class information can be dumped without any issues. Yeah, so by default, I mean when you buy a new iPhone, what are the applications like camera and calculator? These applications are not encrypted. Only the applications that are downloaded from the App Store are encrypted, and you can use it decrypted using Clutch that I just showed you. And this is the usage for Clutch that we just saw. And you can just give the app ID and it will decrypt the application. Okay. Uh, Again, this is just showing how you decrypt an application, copy it to your device, and then again use class dump Z. Okay. Now let's move on to Cycrypt. Cycrypt is another pretty awesome utility. What it does is that I told you that most of Objective-C is a runtime language, right? So it decides the method implementation during runtime. What Cycrypt does is that it can hook into a running process. It's basically an instrumentation tool. So it can hook into a running process while it's running and actually modify the implementation of a particular method while it's running for that particular instance of the application. Okay. So instead of just like going through Cycrypt, I'll just show you a demo. So as I told you, this is wait. So okay. So this is this application. Okay, it has a jailbreak test. It checks whether the device is jailbroken or not, and it will show you a prompt. Okay. Now, what if I want to patch this method? No, not patch, but for this particular instance, modify the implementation in such a way that it's not able to detect it. Okay. So for that, I can use Cycrypt. So let's. So, but another thing that you need to know is that to to actually patch this method, you need to first of all find out which method is this. Okay, jailbreak test one. Out of all the methods, 100 methods in a particular iOS application, how can you find which method is being called? Okay, so we'll go through that, right? So I'm connected to my iPhone right now, so I can run Cycrypt just like this, but I'm going to hook into a particular application. To hook into a particular application, you need to find out the process ID for this particular application. Okay, so the process ID for DAM vulnerable iOS application is 1700, and I can hook into this method by using the -p command. Okay. Okay. Okay, so now I'm inside the application. You can basically write your own code now. So if I do a UI app, it basically gives me the instance of this application. Okay. Now this part that I'm doing, it requires a little bit background about Objective-C, which you can like read very easily from the documentation. It just takes an hour. So to find the delegate, you can use UI app.delegate. Okay. This is the delegate class name, and it also gives you the address for that. Okay. Now, another thing that's there in the application is the key window, and it has a particular property called root view controller. Okay. So as you can see, this is EC sliding view controller. So what could be the sliding view controller in this application? Like I'm kind of confused. I'm thinking it's probably this thing, sliding, right? So I'm thinking this is the main view controller, and all these different screens are view controllers on top of this sliding view controller. Okay, so to find out the, so we already know this is the sliding view controller. Okay, now by looking at the class information, you can see that these root view controllers are nothing but a property named top view controller inside a root view controller. We can also see that here if we go inside the class info. So let's search for EC sliding view controller. Okay, so this is the EC sliding view controller. What are the properties that it has? Okay, it has a top view controller storyboard. It has a under view controller and under left view controller, and it also has a top view controller. So this is the information that I found using class dump. Okay, so I can look for EC sliding view controller in the class information. After that, I know there is a property named top view controller. This looks interesting. You can just find the reference of top view controller by just going here. So now I'm going to look for top view controller. Okay, this is the top view controller. Now this is UI navigation view controller. What is navigation view controller is that it's the first view controller in a navigation flow. Okay, so if I'm inside jailbreak detection, as you can see, this is navigating back and forth, right? So this is a part of a navigation. Every navigation view has a particular navigation controller, and this is the top part of that. This is the first view controller in that. To again find my current view controller, I can again do this top view controller. And this is the actual screen, jailbreak detection VC that I'm on right now. Okay, this is the actual screen. You can easily see just by the name, jailbreak detection VC. VC is view controller. Told you that VC means view controller, which is a different screen. This is the particular view controller. Now in this particular screen, I can find out which method is jailbreak test one, right? So let's again go to class dump and look for jailbreak detection VC. Okay, this is the particular view controller, and over here I have a lot of methods. Okay, so which method do you, which method do you think is the one corresponding to this jailbreak test one? It's jailbreak test, sorry? It's not visible? So what's the problem? Nothing? Okay. Okay, so jailbreak test one tapped is the method that gets called, okay? But this method also looks interesting. Is jailbroken, and it returns yes or a no, okay? So I think this is the method that actually checks everything, and if it's yes, it will return yes. If it's no, it will return no, okay? Now, the other thing that is important is to find this method in Cycrypt, okay? Because we're just looking it in class dump C. But you need to find a reference for this in Cycrypt, okay? To do that, you can, for a particular view controller, you can just do this. You can copy the jailbreak detection VC. You can copy the class name. Oh wait, shit. Yeah. You can copy this class name and do messages. It will give you all the particular methods for Cycrypt. Okay. So this looks pretty big, but hey, our method is at the very start. Okay. I did not do this intentionally, but just came like this. Okay. So now you can find the reference for this method. And if you want to modify an implementation, now Cycrypt is basically a bridge between Objective-C and JavaScript. Okay. So it's okay if you have Objective-C on the left and JavaScript on the right. Okay. It sounds very weird in the beginning, but this is how it is. Okay. JavaScript on the left and Objective-C in the left and JavaScript in the right. Okay. So to modify the implementation for this method, I already wrote the particular command. So yeah. Okay. So in dot messages, you find is jailbroken. Okay. Now you can just replace that, find this particular method like this. If you do this, you're basically referencing a particular method in the messages. Okay. Let's just leave this like this, and this is what we actually want to put. Okay. So jailbreak detection dot messages. This will give you a reference of all the methods. If you give it the particular method name in the square brackets, it will reference that particular method. And on the right side, you can have JavaScript. So you can have a method that will return no every time, regardless of what happens. Okay. But remember that this is only for the time this application is running. We will later look at how you can modify it permanently. Okay. So if I do this, so now it returns no all the time. So if I say jailbreak test, the jailbreak will return no, which means the device is not jailbroken. So instead of showing device is jailbroken, it should show something else, right? So if I tap on it, it says device is not jailbroken. So, but remember, if I close this application and run it again, this will go away. This is only for this particular runtime. Okay. So this is how I do it. Okay. So let's just go through Cycrypt quickly. So we already show you UI app and UI app.delegate. Okay. Some of the cool things that you can do with Cycrypt is you can find in this link, Cycrypt tricks. Okay. I can share the slides with you after the presentation. Another thing that you can do in Cycrypt is you can write your own functions. Okay. So, and then you can use those functions and give it parameters. So if for example, this is a particular method which is print methods. I found this from the documentation. It's already there. So you can define your own method called print methods. Okay, now this method is already defined. Now I can use this method. So I can say print methods. So app delegate. And it will show me all the methods for app delegate. Okay. So this is how you can define your own particular methods. I would really recommend that you check out the documentation for Cycrypt and look at all the cool things that you can do with it. Okay. And as I already showed you, you can use the messages property to find out the methods. But remember that the messages property will only give you instance methods. Okay. If you want to look at the class methods as well, which starts with a plus, you can use this isr.messages. So let's do that as well. So app delegate isa.messages. This will give me all the class methods. Okay. Oh, there is a misspell. And this will give me all the class methods as well. Now this could be very intimidating at first, but as you start practicing, you'll know that it's actually really simple. Okay. And the other good thing is that the methods actually tell you what they're doing in a very good way. Is jailbroken. So it's very verbose, right? You have a question? Okay. So we just did a practice of runtime manipulation using Cycrypt. This is just the, what do you say? This is the slide that explains it. Now another challenge in this is, let's go to the runtime manipulation section. And let's do the third third challenge, which says tapping the button below will load a tutorial from a particular URL. Use runtime manipulation techniques to load content from a different URL. Okay. Now in this case, what you're doing is that instead of changing a method, you're changing a particular property. Okay. Because the URL is already hard coded in the application. Now you're just changing the name of that property. Okay. So again, you can do that very simply with script. Just to save time, I will already written what is the command for it. So yeah, this is it. So let's see what it loads now. Oh, we don't have internet. Apparently the network is not working. So let's see. Okay. Is this network working for anyone? Okay. Okay, we'll not do this because it's having some network issues. But yeah, this is how we do it. Just by using this method so instead of in methods you use dot messages, right? Over here you can just reference the property with the dot. So dot URL to load, and then again on this side you have Objective-C code. Okay, so you can use that to find the name of the property. Now let's just validate it. Okay, so first let me just print the value of this property. Wait. It's not printing. Okay, apparently you cannot print variables, but you can change it using this. Okay, it will work. It's pretty straightforward. Okay, so yeah, let's move on. And I already showed you how you do runtime manipulation. Let's do another exercise in runtime manipulation. In this case, the challenge is bypassing a login screen. Okay, so if you go here, there is a login screen. Okay, if you tap on login method 1, it says incorrect username and password. Doesn't matter what you enter, it will show you incorrect username and password. Okay, so how does it work internally in the application? Obviously there will be some method that will check whether the username password is correct or not, and it will return true or false, and then depending on that particular parameter, either you'll go forward or they'll just show an alert. Okay, again using the same techniques that we just discussed, we can find the method name and we can modify it. Okay, so in this case, this class name is runtime manipulation details VC. Okay, again we do dot messages, and this method is login validated. We always return yes. Okay. Okay, so now again this method is patched for this particular instance of the application. So if I go to login method 1 again, okay, let me do it again.
Excuse me.
Yeah.
Can you modify the application and make it executable?
Yes.
And sign it?
Yes, we will do that. But that's the extreme end. You want me to show it now? It's pretty good. I can do that, but we'll get into that as well. Okay, but you need a licensed version of Hopper. But it's only $90. It's very good value for money, because if you buy IDA Pro or something like that, it usually costs thousands of dollars. Hopper, for the value of $90, is really good value for money. So you just make it executable by self-signing it, and you can run it on a jailbroken device. Okay, we'll look into that. So this is how you modify the implementation. Now it will work for sure. And if I click on login method 1, now it has patched this method. Okay. So really recommend to download this application, download Cycrypt, and get your hands dirty on it. Okay. Okay, now we'll move on to a different kind of vulnerability, which is insecure local data storage. There are many ways in which you can actually store information on a device. Okay, many different libraries, many different frameworks. And most of the time developers, they don't know how to store, so they just find the easiest way. Okay, so there are like 4 different ways. Actually there are 7 or 8 different ways. Igor added a lot more issues into this, so we'll look into the first 4, and then Igor can take you a walkthrough of the other ones. So there is property list. Let's start with property list. Okay, now whatever data you store using property list, property is nothing but a plist file which is stored unencrypted in an application sandbox. Okay, an attacker doesn't even need to have a jailbroken device to access the contents of this plist file. Most often developers make a mistake of storing this data because it's very easy to implement. Okay, it's just, property list is just different key value pairs that you store in an application. Okay, this is the sample code for this. As you can see, it's not even 6 or 7 lines of code to store the data, so it's really simple to implement. And now let's go to this application. Go to the insecure local data storage section, go to playlist and store some data. Okay, so I'm gonna save phdays and phdays. Okay, so data is stored in the playlist. Now a developer can use this to actually store credentials, authentication tokens, session IDs, like confidential information using this. Okay, so but where is it, where does it go? As I told you, it's there unencrypted in our application sandbox. Okay, so if I go here into my application, this data gets inside this particular plist file. How I found that it's userinfo.plist and it's not some other file? Well, even if there are like 10 applications, you can check all of them, so that doesn't matter, right? As you can see, the password is phdays, key is password and string is phdays, and the username is also phdays. Okay, so this information is there unencrypted in our application sandbox. So developers don't know this. This is a very serious vulnerability. Actually, LinkedIn was found to store username and passwords in clear text 2 years back, 2 or 3 years back. So this is a very serious vulnerability. And what I can do is that, hey, I just need an iPhone for 2 minutes. I'll connect his iPhone to my laptop, analyze it using iExplorer, copy the plist file on my device, and then give it back to him. No, doesn't take even 1 minute. Okay. Similarly, there is another way of storing information, which is NS user defaults. NS user defaults is basically used to store information that persists even after the application is closed. Okay, it's basically used to store small properties like, for example, if a user wants to log into a particular application, the remember me thing, remember me key value pair could be used to store in NS user defaults. Again, this content is stored unencrypted in our application sandbox, and it goes to a particular location, which is, so let me go to this application again, go to NS user defaults and store some information like hello days and save it. Okay, now I'll go to iExplorer, and this information always goes inside this particular folder. It goes to library, preferences, and this particular file. Okay, there will be a file named application with your application ID, which is com.highaltitudehacks.dvi.plist, and you can look inside it, and you can see the hello phd string is there unencrypted in our application sandbox. If you can look this one, oops. Okay, this again very serious issue, and a lot of applications have been found to store data unencrypted. You don't even need to have to jailbreak a device to find this information. Okay. Okay. Another thing is core data. Core data is basically a framework. It's basically used if you want to have complex databases like relational databases in your application. All this information is basically stored using SQLite files. Okay. Again, this is stored unencrypted in an application sandbox. All the applications are .SQLite files, and like you can just use any SQLite client or a SQLite GUI utility to explore this information. Okay, and this is a quick demo of this SQLite browser application that I use. You can basically find all the database info. You can copy the SQLite files to your device, to your laptop, and explore it. So as you can see, this SQLite files, they look interesting. So let me copy them to the hello world folder. Okay, So these are the files that I've downloaded from the application onto my device. Okay. And now I can go to this folder, and I can use a nice utility named SQLite browser to analyze the code which is there. Okay. And now you can basically browse all the data that is inside the application. These are the different tables. Just have a simple username, and here's Igor's username and password and his phone number if you're interested. So everything is there unencrypted. Okay. So SQLite, NS user defaults, playlist, core data, all the information is unencrypted in an application sandbox. Doesn't require a jailbroken device to find it. Okay. Now, keychain. Now, this is actually the most secure way of storing information on a device. Okay. Most of the popular applications, they use this to store information. Okay. Now, see, the thing is, at the end of the day, you're storing data locally on a device. Okay. No matter what you do, if I have the device with me, if I spend like, even if I can spend 5 or 10 years, but ultimately at the end of the day, I will be able to crack the code, right? So this is the final place where everyone goes to store their information. Unfortunately, this encryption is also broken. So you can download utilities to find the information on the keychain. But if you report a developer saying that you're storing confidential data in your keychain, they will not recognize this as a vulnerability, because they think that you have jailbroken a device, you are responsible for that. What people are starting to do now is that instead of storing actual credentials, they're storing access tokens, right? So it's a bit harder, like access tokens or session IDs. So it's a little bit harder to actually find, even if you find the information, to actually gain access to that particular user's accounts. So, and you can download this utility called Keychain Dumper to dump this information. Okay. Uh, Storing information in the keychain is really simple. You can use wrappers like this, keychain item wrapper, allocate it to the identifier, and then you can store the identifier. There is a thing called access group, is that if two applications are using the same access group, they can share the information with each other. Okay. Now what this utility keychain numbers does is that it uses a access group with asterisk sign, which means all. Okay. Now usually Apple will not accept this kind of code in their own applications, but you can run this code on a jailbroken device, and that is what keychain dumper does to dump information from the keychain. Okay. So we'll just have a quick look at keychain dumper. Okay. So once I do this, it will show all the passwords that I have on my personal phone. So I'm not gonna show you for a long time. So this is everything. Okay. These are all the things that I've done last 2 years, all the passwords, all the access tokens. I can show you one thing, the network for my GoPro Wi-Fi password. The password is hello world 1. Okay. I can show you that. That's it. Okay. So a lot of information in there. Okay. But if you basically report a vulnerability saying that you're storing username and password in a keychain, then that's a vulnerability, because they should not do that. You can store access tokens. That is the correct way to do that. Store access tokens or session IDs which can actually expire after some time, not something like user credentials, right? So before I hand it over to Igor, I would just like to show you one thing, how to self-sign an application. Okay. This is because this guy just asked, so just small demo. So to self-sign an application, you can use this utility called LDID. Okay. And signing an application is as simple as using LDID -s for sign, and then give it the application binary. Okay. And this will just self-sign the app. Okay. So, but we'll look into this at the end. So now I would like to hand it to Igor.
Это самая, в принципе, сейчас популярная NoSQL база как для iOS, так и для Android-приложений. Как и во всех остальных случаях, все данные хранятся в открытом виде в папке Documents, песочницы приложения. И просмотреть их можно с помощью утилиты Realm Browser, написанной самими разработчиками базы. Давайте вот демку небольшую пробежимся. Тут как-то еще можно выводить на экран, да? Сейчас. Сработало. Ну, введем какое-нибудь имя пользователя, админ, пароль и сохраним в базе. Теперь переходим в iPhone Box, песочницу приложения, Documents и вот файл default 3, стандартное название для их базы. Ну и вот так выглядит в реальном браузере эти сохраненные данные. Вот, я до этого еще что-то сохранял, вот админ пас. Кстати, вот в DVIA помимо Realm можно также поиграться и с другими сторонними базками, Yap Database и Couchbase. Ну, вот так, как я уже сказал, выглядит, собственно, этот браузер с открытыми данными. Думаю, все присутствующие в зале уже либо слышали про Apple Watch, либо даже успели их потрогать. Напомню, что Apple Watch работают с айфонами, начиная с 5-й версии, и с iOS, начиная с версии 8.2. На конференции Sun Security West уже буквально пару недель назад был доклад касательно уязвимости Apple Watch, и касался он синхронизации пользовательских данных между девайсом и часами. Мы сегодня поговорим именно о сторонних приложениях на Apple Watch. Вообще, что сторонние приложения? На самом деле, на часы пока еще невозможно разрабатывать нативные приложения. Все, что есть, это экстеншены соответствующих приложений с iOS-девайса. Возможно, вот на грядущей WWDC будет представлен новый SDK для разработки нативных вещей, но посмотрим. У экстеншена на часах и у самого приложения нет доступа к контейнерам друг друга, поэтому для обмена данными используется shared контейнер. Скорее всего, когда практик уже показывал файловую систему iOS-приложения, вы видели там папочку shared. Вот, var mobile container shared. К сожалению, на iOS 8.2 и 8.3 еще нет нормального джейла, поэтому демо мы показать сегодня не сможем. Но, тем не менее, все уязвимости, о которых говорил практик, связанные с несекьюрным хранением данных, полностью распространяются и на часы. Помимо уязвимостей, связанных просто с несекьюрным хранением данных, в iOS также есть несколько таких сторонних каналов утечки. Во-первых, это системные логи, снапшоты, буфер обмена, пользовательский клавиатурный словарь и куки. Пройдемся по каждому. Вообще, что такое логи, как они вызываются? Для того, чтобы что-то вывести в консоль, используется функция nslog. То есть то, что мы скармливаем, появится у нас в консоли. Проблема в том, что многие разработчики забывают выпиливать вызовы этой функции в приложениях, которые выходят уже в продакшн. Соответственно, просмотреть эти логи достаточно просто. Достаточно всего лишь подключиться в Xcode к текущему устройству. Перейдем к демо. Введем какие-нибудь данные. Теперь перейдем к Xcode. Открываем окно с устройствами, текущее устройство. И здесь, к сожалению, очень мелко, но вот можете мне поверить, что вот здесь как раз-таки то, что мы скормили nslog. То есть имя пользователя, пароль и email. Как с этим можно справиться? Есть три пути. Первый вариант: можно вручную перед релизом приложения ручками выпиливать все функции nslog, но это не путь джедая. Второй вариант: мы сразу же можем все вызовы функции nslog окружать специальными препроцессорными директивами, таким образом, что в релизную сборку этот код автоматически не попадет. И последний вариант, самый на самом деле простой: использовать какой-нибудь сторонний фреймворк, к примеру, какого Lumberjack, где все это уже по дефолту сделано. Снапшоты. Что такое снапшоты, зачем они нужны? Представим, что мы пользуемся приложением и выходим в бэкграунд. Когда мы 2 раза нажмем на кнопку Home, вот даже сейчас сразу покажу. То есть вот у нас есть приложение, мы сворачиваем, выходим в свитчер между приложениями, и вот это не... На самом деле это просто изображение. То есть как раз-таки это и есть тот самый снапшот. Когда мы снова открываем приложение, мы сначала видим этот снапшот, и потом потихоньку под ним подгружается UI. Казалось бы, очень хорошо и круто, но проблема в том, что на эти снапшоты спокойно могут попасть какие-то чувствительные данные, там, не знаю, номер кредитки, пароль, цифровой код, что-нибудь в этом духе. И эти снапшоты хранятся в открытом виде все там же в песочнице приложения. Вот так примерно это выглядит. Давайте снова в демо. Как зовут мою собаку? Здесь нет русского языка. Сворачиваем. Заходим в Library, Cache, Snapshots, папку и открываем тот снапшот, который был сделан. Вот так в абсолютном открытом виде все это дело и хранится. То есть как побороть эту проблему? Уже нет на это слайда. Но тем не менее, во-первых, можно отключить этот функционал, то есть вообще снапшоты делаться не будут, но выглядеть это будет очень печально. Другой вариант, мы можем спокойно вклиниться в приложение в тот момент, когда этот снапшот делается, и вообще абсолютно любым образом либо заблюрить какие-нибудь его части, либо замазать, либо вообще исключить. То есть, в принципе, простор для фантазии есть. Буфер обмена. Все данные, которые копируются в iOS-приложениях с использованием встроенных функций cut и copy, и стандартных текст-филдов, попадают обычно в общий буфер обмена. Таким образом, все другие приложения могут получить доступ к этому буферу. И понятно, что помимо, там, не знаю, каких-нибудь стишков, туда может попасть и, не знаю, скопированный пароль. Вот так выглядит текст-филд, это стандартное всплывающее меню с функциями cut и copy. И чтобы получить данные буфера, нам поможет снова site-crypt. Давайте попробуем. Введем мой номер кредитки. Одну секунду. Один момент. Так, мы подключились к другому устройству, но там тоже что-то в буфере должно быть. И сейчас увидим, что там есть. Мгм. Спасибо. Немного подлагивает. То. Так. А. И подключились к устройству. И теперь посмотрим, что у нас в буфере обмена. Распечатаем его содержимое. Доступ к основному хранилищу получается вот таким методом. UI pasteboard, general pasteboard. Это массив всех итемов. И посмотрим самый крайний элемент. Ну вот здесь в конце 16 цифр. Это я тренировался на своем устройстве, вводил номер кредитки. Так что все нормально. Вот так в буфере обмена все это и хранится. Как решить эту проблему? Во-первых, у всех текст-филдов в iOS есть такой прекрасный флажок Secure. Когда мы его устанавливаем, чего мы добиваемся? Во-первых, все данные в этом текст-филде будут закрыты звездочками. Во-вторых, мы запрещаем копировать что-либо из этого поля. То есть, если у вас есть в приложении поле, в которое вводятся какие-то данные вроде пароля, обязательно ставим на него Secure. Что еще можно сделать? Во-первых, при выходе в бэкграунд мы можем очищать содержимое текущее содержимое буфера обмена, просто приравнивая его к нилу. И чтобы немного усложнить жизнь атакующему, можно использовать не General Pasteboard, а отдельный буфер обмена для данного приложения по какому-то ключику, который можно там как-нибудь аккуратно где-нибудь зашить. Пользовательский словарь клавиатуры. Вот так. Автозамена в iOS работает вполне таким стандартным образом. Все незнакомые слова, которые система не знает, записываются в словарь. И в дальнейшем данные из этого словаря используются для автоподстановки. Ну, таким образом, туда могут попасть не просто незнакомые системе слова, а и пароль, любой код, вообще что угодно. Причем стоит отметить, что эти данные, в отличие от того, что лежит в буфере обмена, оно постоянно перетирается, данные из этого словаря вообще находятся в системе неограниченное количество времени. То есть такая неприятная вещь. Вот таким образом они хранятся в файловой системе устройства в дат-файлах, префиксом которых является язык, соответствующий этому словарю. Ну и вот внизу можно посмотреть, как примерно структура этого словаря выглядит. Если хотите сфоткать, могу вернуть. Ну, я думаю, слайды потом выложит, мы уже договорились, что передадим, поэтому с этим все должно быть хорошо. Многие приложения хранят в своей директории также и куки, в которых могут быть как Session ID какие-нибудь, так на самом деле и пароли пользователя. Вот таким кодом NSHTTP Cookie Storage, Shared HTTP Cookie Storage, SetCookie можно сохранить любую куку в Persistent Store. Путь к кукам такой же, в принципе, как ко всем другим данным. Они лежат в песочнице приложения в папке Library. Как просмотреть данные этих кук? Довольно просто. Есть чудесный питоновский скриптик binary cookie reader py. Нужно всего лишь скопировать эти куки себе на устройство и прогнать через этот скрипт. Вот, к примеру, так выглядят куки мобильного приложения Аэрофлота. И давайте посмотрим демку нашим чертовски уязвимым iOS-приложением. Имя пользователей. Нет, здесь челлендж работает немного по-другому. Здесь уже какие-то данные зашиты. Я вспомнил. Сразу перейдем в iPhone Box. Cookies. Вот те данные, которые уже были зашиты в приложении в куках. Вот видите, password, dv-password, username, admin 123. Ну, так довольно просто можно просмотреть их содержимое. Так, насколько я помню, дальше я обратно передаю слово моему коллеге.
Now, have you ever noticed that you're browsing you're browsing Safari or Chrome in your app in your mobile, and suddenly it will open some other application. It will open Facebook or the App Store. Okay. So how does this communication work? Okay. This is what we call inter-process communication. It happens using something we call URL schemes. Okay. So every application has the authority to they can register for a URL scheme. Okay. So what is a URL scheme? So assuming I have the Facebook application, I registered for the URL scheme FB. Okay. Now any URL that opens with FB will invoke the Facebook application. Okay. Now how can this be useful? So let's take of another think of another application called Skype. Okay. So assuming I build the Skype app, I want users to be able to call a number in Skype from some other application like Facebook. Okay. So I'm browsing Facebook and I see a button which says call Skype. When I tap call Skype, it should invoke the Facebook Skype application and it should call that number. Okay. Now is that a vulnerability? Yes. If there is no check, then it is a vulnerability, because I can also make another malicious application that will automatically call this button and it will invoke the Skype application and call that number. So that could be used for spamming. So the Skype application at its end should also validate whether the request is coming from a authorized source, or it should show an alert saying, "Are you sure you want to call this number?" That's what happens in most of the numbers. So okay, so I'm on. Wait. Okay, so I'm on. Let's go to Safari and type this. Okay. As you can see, I typed FB in Safari, but it opened. It's open. My friends, sorry about that. But it opened the Facebook application. Now, how did this happen? It's because FB is a URL scheme that is registered by Facebook. Okay. So any URL that starts with FB will open the Facebook application. Okay. Now after that, whatever I type as parameters, will be validated by Facebook to perform certain actions. Okay. Depending on the parameters that are provided here, it can do a lot of actions. It can also have a call button. So if I type that call button, the request will start with FB, and in the parameters it will have phone number. On the end, on Skype's end, it will check whether it's coming from a particular registered source like Facebook. It will check if the phone number is valid, and then ideally it should show an alert before making a call saying, "Are you sure you want to call this number?" Only after that it should allow the communication to happen. Okay, so we have this kind of vulnerability in our application as well. So yeah, so it comes under the category security decisions via untrusted input. Okay, so here's the challenge. Assuming this application has the authority to call a number. Okay, your task is to actually uh, using Safari call the number from this application. Okay, how can you do that? First of all, the important thing to do is to find the URL scheme that this application is registering for. Okay, so it could be FB, it could be FA, it could be DVI, whatever. How do we know that? Okay, again you can do that using iExplorer. So you go inside this application, and then you go inside Okay, so this, okay, so I have to go inside another plist file which is inside the application bundle, but it goes inside this file, info.plist. Uh, Wait, let me see if I can use it using hyphen box. No. So yeah, so this is the file. Okay, now this file is not inside the data container, it's inside the bundle. Okay, now what is the difference? I explained data contains the data, whereas the bundle contains application binary and all the images that is using. As you can see, it uses a lot of images. Inside it is a file called info.plist. Okay, this will contain information about the URL scheme that you use. Okay, so let's just open this. Okay, over here you can see URL types. Okay, here you can see some items. You can see URL schemes, and you can see the URL scheme is DVIA. Okay, so now any URL, that means any URL that opens with DVIA will invoke this application. Okay, so let's just validate this. Now, can you register for a URL scheme like HTTP? You cannot, because browsers register for that. Only browsers have the power to do that, and that's what happens when you set something as a default browser. It registers HTTP, HTTPS as a URL scheme. So whatever URL you open that starts with HTTP or something like that will invoke the browser and open that particular URL. Uh, so, um, so if I go to Safari and open URL. So it says open this page in DVI. Okay. Now, as you can see, last time it did not show up. Sometimes this is not a feature that I have implemented. It is a feature that Safari has implemented because it doesn't trust my application. Okay. But usually that's not the case. Okay. So it opens the application, it does nothing. Okay. But our challenge is to call a number using this vulnerability. Okay. Now again, I'll follow the process is the same. Okay. You look for the particular method. This method name always is it goes inside this method called application open URL source application. You disassemble this method using hopper. You see what's going on inside that. Okay. So let's go through it very quickly. Uh, Okay, this will take some time. So the process that goes behind this is that you disassemble this method, okay, see what's happening inside this, and then using the disassembly, you find what are the parameters this application is looking for, okay. Is it looking for a phone or something like that, okay. Uh, let's see if you can find it using Hopper. And this thing might not be very straightforward, okay. Sometimes it's basically just on a guesswork. So as you can see, I have disassembled this method. By the way, last time I was not able to show the pseudocode feature because it was a 64-bit binary. Now this is 32-bit binary. So over here in labels, I go to open URL. I find this particular method which handles URL schemes, and I click on this button, and it will show me the pseudocode. This is, I think, the coolest feature of Hopper. It's able to disassemble a particular method, and you can, like, it's not very clear, but you can find out certain things, okay. Now what does this look? This looks like a part of a URL, okay, and you can see that it's looking for a parameter called phone, okay. Depending on certain things, it can call a particular number, okay, with success, or it can go over here to this loop, which I don't know what does, but I want to go here, okay. This is my task. So I think what it is doing is that it's looking for first of all, it's looking for this thing in the URL, and then it's looking for a parameter with the name phone, okay. Using this knowledge, I can construct a URL that will have all these things. Okay, now I already done that, uh, and here is how it looks like. Wait. Yep. So here's how it looks like. Okay, this starts with DVI because this is a URL scheme. I don't care what URL is this, because I think it's not checking for it. Okay, it's only looking for this thing in the URL. Okay, and then I give a parameter phone. Okay, so this is what's happening. So if I type this URL in Safari, it should invoke first of all the DVI application. This success will pass, this check will pass for call number, and this phone number check will also pass. So ideally, should call a particular number. Okay. Now, obviously, my app cannot call a number, but I will show that it's working by just showing a prompt. Okay. So I'll go back to my app. I'll go to Safari, and I will construct this URL. Okay. I have already copied this URL over here, second one. So I'm just going to tap on it, and it should invoke the application. Maybe something in this URL is not right. Oh yeah, you can see some stuff, free Wi-Fi after this. Okay, so this is the complete URL. Now I'm pressing on go. It invokes this application, and you cannot see it here, but you can see success calling whatever. I think it's some bug with QuickTime, but you can see there's a prompt saying success. Okay, let's see if I can. Yeah, so see. Okay, so now this check is passed. So how could this be a vulnerability? Assuming this is Skype, I can create an application that will call that particular URL. That particular URL will invoke the Skype application and call a random number that could be used for spamming attacks. Okay. So on your end, it's very important that you validate which application is calling this method, and you can easily validate it. It's not a big deal. Okay. So it's not that hard to implement as a developer. Okay. So every time you see a browser opening some other application, it's because it's using URL schemes. Okay, it's not magic. Okay, so now we come to analyzing network traffic. Unfortunately, my Wi-Fi network is not working, so I don't know if I would be able to show you this, but I think I'll just go through the slides because I think all of you know how to set a proxy, right? It's very simple, and a lot of you must have worked with Burp Suite, right? It's just you just set a proxy. So I'll just go through the slides because unfortunately my Wi-Fi is not working. I checked it over there as well. It's not working. So a lot of people connected to the same network. Okay. So why is it important to analyze the traffic? Because in a client server application, you can see what are the things that are going through. Is there any sensitive information? Are there any API keys? Are there any session IDs that are going through? And also, while you're auditing an application, you should also audit the server side, right? So you can scan the server side also by using the data that's going through. So, and you can also manipulate the request response, okay, and see how the client side application reacts to it. You can modify the request as well as response, okay. And you can look for credentials, authentication tokens, something that's important, which is going. That's how you set a proxy. You use Burp Suite, okay. I'll just show you a quick demo. So I have the professional version, but you can do everything in the free version as well. So okay, it's there. Okay, so you go here, you go to options. Over here, you can set the proxy. Okay, go to specific address, and you can select. I don't have an IP address because I'm not connected to a network. But this is what you do. You get a I just connected. So let me see if I can connect from a phone as well. I think we can see a demo now. Okay. Okay, so this is my IP. Okay. And I can run this on a particular port, in this case 8080. Okay. So this is now the proxy is running. Now it's running. Close. And on my phone, I can go to here. I can go here. I can go to manual, and I can set this as my proxy. So 172.20.4.89, and then over here I can give the port as 8080. Once this is done, okay, once this is done, now I can see the traffic that's going through. So if I go to DVI, I can see already some traffic which is going through. Let me go to transport lead security challenge in DVI. Okay, I'm going to send some request like a fake card number, a fake CVV, and a fake name over HTTP. As I send this, it says request sent. Over here you can see a request that is being sent, and you can see the information is being passed in clear text. Okay, this is a very basic check just to make sure that you can analyze the traffic which is going through your device. Now, can I also check traffic which is going over SSL? Well, definitely you can. What you need to do is that you need to install a fake certificate on a device. Burpsuite does this doesn't do this automatically, but what you can do is that you can go to this particular URL which is burp. Okay. Uh, Connection is slow, but what you do is that you install a fake CA certificate and accept it, like accept all the installation instructions. And okay, so here it is. So go here and go to CA certificate. Okay, this will download a certificate on your phone, and you need to verify it. You need to install it, and again confirm. It says profile installed. Okay, and now you can see all the HTTPS traffic that's also going through. Okay, so now instead of sending data over HTTP, so now as you can already see, I'm starting to get HTTPS traffic. Okay, now honestly this certificate was already on my device, so even before you were seeing the traffic. But if you don't have the certificate installed, you cannot see HTTPS traffic. So you can see HTTPS traffic here as well. Okay, so yeah, that's how it's done. It's pretty straightforward. And once you know which target to attack, you can right click, and either you can do a passive scan or you can do an active scan. Okay, this functionality is only available with the professional edition, but you can do a passive scan, and you can also do an active scan. Okay, sure. Over here in the scanner, you can see all the vulnerabilities that it's finding. Here you can see the scan queue, all the requests that's making, and over here you can see the results. Okay, so it's starting to identify some vulnerability, but honestly a big scan will take around 10 hours to 12 hours. So that's what I do. I browse through the entire application, I select everything, and I say do a passive and active scan. Okay, and it just keeps scanning. I go to sleep. Next morning I wake up, it finds some issues. Okay, so this is how you audit the server side of the application. Make sure the client to server communication is secure. Even if you're sending some data like confidential data that is like a password, Burpsuite will identify it. Okay, so this is actually given to by my office, like Emirates. I work for Emirates, but even if I'm using it just for personal reasons, $299 for something like Burpsuite is good value for money. Okay, so yeah. Okay, so this is just the slides that shows you how to analyze traffic. For HTTPS, you need to install the certificate. You'll get a warning. Install it, and you can do it. Now, another thing I wanted to talk about is certificate pinning. Okay, certificate pinning is used. What it does is that it, instead of checking the server side for proper client side proper public private key exchange for where that happens in HTTPS, it hard codes the certificate in the application binary. Okay, so assuming I am making a Twitter application, I already know that I'm only going to communicate with the Twitter server. I don't want to communicate to any other HTTPS website. So I'll hardcode the certificate in my application binary, okay? And once the communication is happening, I'll check if the certificate is valid or not, because this thing is hardcoded in my device. So instead of you cannot install a fake, you cannot use a fake certificate to validate the transfer in this case. So this is what some applications use, mostly banking applications and applications like Twitter and Square. So how do you get past this? Okay, now I told you something about a runtime manipulation attack. Okay, so there's something called mobile substrate tweaks. Okay, in iOS, what it is that it's just is a simple some lines of code that will patch an entire binary forever. Okay, it uses the runtime manipulation technique to modify an application binary permanently. It doesn't modify the disassembly, but it's like a script. For example, it takes a method and it modifies the implementation permanently. Uh, so that's what we call tweaks. Okay, and whenever you start this application, this tweak gets loaded into that application by default and modifies that particular method. So what this tool does, there's a tool called iOS SSL Quick Skill Switch. It checks that particular method where it's validating the certificate signature, and it returns yes every time. So no matter what you do, the certificate validation will always become true. Okay, and so this tweaks, once you install this tweak, you can see the traffic from Twitter as well, as you can see from the slides. Okay, now just to know, just to find out whether the tweak is working properly or not, you can go to devices, select the device. Okay, now look here, these are the device logs. Okay, now whenever you install open an application, some libraries get loaded like the tweaks. You can see it whether it's successful or not. Okay, so I'm here right now, and let me close this application and open it again. Okay, so I opened DVI and something happened in the logs, something's happening. Okay, so as you can see, initializing, it's saying it's initializing some tweaks. Okay, and here you can actually see these tweaks being loaded into the application at runtime, and if there is some error, you can see it in the logs. Can you see? It's very hard to see, but you can see the word tweak, right? It's loading a lot of tweaks into the application. So this is where you can actually see and also find out if there is some error or not. Okay, yeah, so now we're going to attack third-party services. Igor will take that. He has done a lot of great work on this in this application. If we go here in this section, attacking on third-party libraries is completely done by Igor. So he will give you a walkthrough of it. Okay.
Сторонних сервисов. Почти во все приложения встраиваются те или иные сторонние сервисы. К примеру, для сбора статистики, сбора кэш-логов, отправки пуш-уведомлений. О как. Отправки пуш-уведомлений, ну, там вообще чего угодно, даже там для авторизации через социалки. И помимо того, что вообще в этих SDK-шках самих есть какие-либо уязвимости, само использование сторонних сервисов открывает новый канал утечки данных. Он появляется потому, что в основном все API-ключи хранятся, в принципе, в открытом доступе, в чистом виде, в исходниках приложения. То есть вот сейчас посмотрим на примере парса, что это такое и как с этим жить. Вообще, что такое Parse.com? Parse.com — это мобильный Backend as a Solution сервис, который вот, практически все плюшки, которые я перечислил, как там пуши, хранилище данных и прочее, вот, предоставляет для мобильных приложений. Поднимается буквально за считанные минуты. Все данные в Cloud Core, это как раз-таки облачное хранилище данных, хранятся по сути своей в обычных таблицах. Ну вот здесь, к примеру. У всех этих таблиц можно выставить определенные права доступа, отвечающие за возможность поиска, апдейта полей, создания, удаления записей. И по умолчанию все эти права доступа выставлены в паблик, то есть разрешены. Что нам стоит сделать дальше? Открываем хоппер, скармливаем ему бинарник нашего приложения и смотрим. Во-первых, вытаскиваем API-ключи, и во-вторых, вытаскиваем имена таблиц парса. Потом, когда мы их получили, мы можем взаимодействовать с парсом вот с помощью его же API. То есть сначала вызываем метод setApplicationID_clientKey, скармливаем ему эти ключики, потом создаем query по названию одной из таблиц, и вот можем спокойно пофетчить все объекты. Но, конечно, то, что мы можем сделать с помощью этого API, зависит от того, какие права доступа выставлены. Для того, чтобы узнать что-нибудь про эти права доступа, я написал простую утилиту parseRevealer, там есть на GitHub, можете скачать, поставить звездочку, пофоркать. Что она делает? Она принимает на вход API-ключи парса и название таблиц. И на выходе выдает нам права доступа для всех таблиц и структуру классов. Ну, давайте на примере DVIA посмотрим весь процесс. Открываем хоппер. Так, с чего начнем? Найдем метод Application Finish Launching. Это стандартная точка входа в iOS-приложение, находится в app-делегате, о котором мы уже сегодня рассказывали. Чаще всего именно там происходит подключение к различным сторонним сервисам, конфигурация приложения и прочее. Ну вот мы его нашли. Откроем псевдокод. Так, смотрим, это нам неинтересно. Да можно и здесь, и да. Вот видим вызов метода setApplicationID_clientKey у класса parse, и прямо перед этим объявляются как раз-таки его ID-шники. Введем их. Подключимся, надеюсь, интернет не отвалился. Отвалился. Подключилось. Так, теперь нам нужно выяснить название таблиц парса. Проще всего это сделать, поискав метод parseClassName. Этот метод есть у всех наследников корневого PF-Object. Вот сабклассы PF-Object, по сути, это классы, которые соответствуют определенным таблицам в парсе. И у каждого из них есть такой метод, который вот как раз-таки отдает название этой таблицы в парсе. Вот second parseClassName. Ну ладно, будет зелененьким. И то же самое есть first parseClassName. И посмотрим, какие права доступа у этих классов. Ну вот у second parse класс true, find, create, delete, update и get установлены в true. То же самое для first parse класс. То есть абсолютно, с данными, хранящимися в этих таблицах, мы можем сделать абсолютно все. Можем их все выпилить, можем добавить туда что угодно, можем изменить их значение. То есть вообще спокойно. Ну и вот еще посмотрим, какая же у них структура. То есть видим, что у second parse класс есть параметр 3 строка, параметр 4 number, стандартные там поля Object ID, Created At, и какие-то тоже данные по первому классу. Ну, собственно, эта уязвимость, как я уже и говорил, проявляется очень часто, особенно во всяких стартапах, которые по-быстрому нужно подняться, по-быстрому устроили парс, порадовались, и все довольны, пока кто-нибудь тут не залезет, не посмотрит. К примеру, анализировал одно интересное приложение, и там при подстановке нового поля приложение просто вообще подчастую начинало крашиться у всех, там его несколько тысяч пользователей, которые просто откроют. То есть даже такие вещи бывают. Flurry.com – это самый популярный сервис мобильной аналитики. Встраивается практически в каждое первое приложение, я бы даже сказал. Так же, как и парс, для авторизации в сервисе используется API-ключ. Ну, его можно также спокойно найти с помощью хоппера. Что можно сделать с этим ключом? Самый такой простой и очевидный вариант. Мы спокойно пишем свое приложение, подставляем туда этот ключ, и из этого приложения можем дергать абсолютно любые вызовы, абсолютно любые события исходного приложения. То есть мы можем просто подчастую нафлудить сервис аналитики своим конкурентам. Допустим, нам никто не мешает любое рандомное там количество событий сюда подсунуть. То есть вот так примерно выглядит синтаксис Флурия. То есть вот метод startSession, в который мы скармливаем API-ки, метод, который логирует какое-то событие, принимает имя события и словарик с параметрами. И для трекинга открытия экрана вот метод logPageView. И снова передаю слово Ратику.
So for critical applications like banking application, it's really important that they do not allow their application to work on a jailbroken device, because even if you're storing something, some information in a banking application, that is very high significance and you should not allow. So when I do pen testing for my company, if it's like a very critical application, I always recommend to add a check for jailbroken devices. Usually for popular applications like Facebook or Twitter, it doesn't really matter, because even if they apply jailbreak detection, they will lose a lot of user base, because currently there are like more than 20 million jailbroken devices people use for just installing different things in their device. So most of them don't have malicious intentions, so they don't do a check for jailbreak. But if you're using a banking app or very critical app like a corporate app, I would definitely recommend adding a check for jailbreak. So, but there are like many ways to protect a jailbroken device, but the thing is, at the end of the day, the application binary is on your system. The logic is on your system. You are running a jailbroken device and you have all the tools. So no matter what check you put, any skilled attacker would be able to bypass that, no matter what check you put, okay? Because you have the power to patch the application no matter how you want. The only thing you can do is make life harder for him, okay? So So one of the things to check for a jailbroken device is to check whether you're able to create a file out of your own sandbox, because when you jailbreak an application, you lose this application sandbox security feature. So just try if you can create any file in the root folder using some code, and if you're able to do that, then yes, the device is jailbroken. Another thing that people do on their devices is that since most of the jailbroken devices have CDR installed, CDR registers for this particular URL scheme called CDR. Okay, if you're able to do that, then yes, the device is definitely jailbroken. What people can do is that they can jailbreak the device and they can remove CDR, so it's not a big deal. So in this case, this check will fail. Okay, so you need to have a combination of 7 to 8 checks in order to make sure that it's really hard for him to bypass that. You can also check for certain files that are only there on a jailbroken device, but again, I can always change the location of those files. So again, that's not a foolproof check. But yes, if you combine 6 or 7 checks like this, then it becomes difficult. Okay. But what if everything is in a method is jailbroken, everything, every logic, then you can just modify the implementation of is jailbroken, right? Again, that's another bypass that you can do. So we'll look into all that. Yeah, so combining all those methods, this is like one method that you get. It checks for certain file paths, okay? Uh, and it also checks whether you can write a string to a file. It also checks whether it can open the URL CDR. But is this function foolproof? First of all, no. And because of this signature as well, okay? It says is jailbroken. I can easily use Cycrypt to patch this method to return no every time. So that doesn't matter. So this should not be a standalone method. First of all, this kind of code should be in different places in methods that's not hard to find. What people do is that sometimes they don't name the methods by what is supposed to do. So if instead of this method is jailbroken, I can write change color, to an attacker, that might not be very useful, but you know what's the logic inside this, right? You are actually writing some very important code, so he will not even look into that method, but someday he will find it, because if he goes to change color method and he disassembles it using Hopper, he'll say, oh, okay, you are doing this, you're doing this checks and all. So he'll find that. But then again, some developers do that. It's because, again, at the end of the day, the attacker has the binary, he has all the class information, so he can bypass it. So you can use all these little techniques to make sure it's not easy. Okay, as I told you, as I showed you before, you can bypass jailbreak detection techniques using Cycrypt by just modifying the implementation. Uh, and you can, it's better to rename the method to something that doesn't look important, like is default color or something like that. So obviously you are ignoring the coding guidelines that Apple provides, but then at the end of the day, the name of a method gives everything away. So it's really important that you, if you're adding jailbreak detection, you add these little techniques to make sure it's even harder. Okay. At the end of the day, he can always look at this method. He can reverse engineer it to see all the checks that are going on inside. So again, this method is also not foolproof. Okay. Another thing I would like to talk about is broken cryptography. Okay. So I have seen this in a lot of applications. People use hard-coded strings in their application binary. Okay. So, like, what else can you do? Okay. Hard-coded strings can be easily found using Hopper, as I just showed you in the string section. So it's not at all good to do that. If you have to store it, anyhow, a string you have to store it. What you can do is that store it in 6 or 7 different parts. Okay, break into 6 or 7 different parts, and then use 3 or 4 lines of code to combine all of them into a string. In that case, it's a bit difficult. So even if you go to strings, you will not see a one string, you will see 7 different strings, because you're combining those strings while the application is running. So it will not be there in the binary. It will only be there during the runtime. Okay, so you can do that as well. So these are the secure coding guidelines. You should not store data using NS user defaults, plist file. Do not store confidential data. Use keychain to store on data like passwords, authentication tokens, and API keys. It's better to just store authentication and API keys and not passwords. Okay. Use proper encryption while storing data locally in any insecure place. Do not use hard-coded keys. Validate incoming URLs using URL schemes. Add checks to detect jailbroken device for critical applications. And again, this is again related to that pasteboard thing. If you're using a password field, make sure that the characters are asterisks, not you cannot see the characters. This can be done by just marking it as secure, a secure field in a text field. Okay. And you can avoid you can also prevent debuggers from attaching into the application using this line of code. What it will do is that any debugger cannot attach to this application because it's denying the attach. This will kind of help because some automated applications, they attach debuggers to the application to analyze the runtime flow. So this will protect it from that. Again, I can always patch this line of code. So it's better to add it in 4 or 5 places, okay, to make sure it's really hard for him. Okay. So I think this is the most important demo that I wanted to show. It might not work because it's a big process. The entire thing is a big process. So might screw up in between, but I'll try anyways. Okay. So patching an application means changing the logic permanently. Okay. This is better than making a change in Cycrypt where you have to repeat the same process over and over again. Because patching an application will persist even if the application closes. Whereas what we did in Cycrypt was only doing runtime manipulation at that instance of the applications. Okay. So some of the tools are Hopper, IDA Pro, and Hexfiend. Once an application has been patched, it needs to be re-signed using LDID before it can be deployed. Okay. So we're going to do this whole process now. So let me load up Hopper. Okay. I'll read. So this is the application binary. I want to disassemble it. Once I open this, I see that it's a fat binary. It has 2 different architectures. Okay. So I can choose any of these architectures. I'll choose ARMv7 because I don't understand ARM64. I understand ARMv7 code. So I'll choose this. Okay. What you can do is you can deploy this as only an ARMv7 device. The other good thing about ARMv7 device is that it can work on 64 devices as well. The performance will not be that great, but it can work. Okay. So your job is done. So I'll choose this. Okay. Now what I'm gonna patch is So in DVI, you have 3 jailbreak detection methods. You have this one. Okay, sorry about that. This one, and in application patching, you have this one. Okay. So instead of patching all these 3 methods, I'm just going to patch the method that shows this alert. So there are like 3 alerts that I just showed you, but basically it's just one method that's being called. Okay. So how do you find the method name? You go here, you say jailbreak, just to look for things related to jailbreak. Okay. You can have, and over here you can say different methods. Okay. This method looks interesting. It says show alert for jailbreak test is jailbroken. Okay. Okay, maybe I can modify this methods and make it to show alert saying that the device is not jailbroken. Okay, can I patch this? Yes, of course I can. So to patch it, first of all, I need to look at the logic here. So I'll do this. Not this actually. Yep, this. Over here that the flow goes to 2 different places. One is on the right and one is on the left. Okay. So either I can easily guess that either it will show an alert saying device is jailbroken or it's not. So depending on that, it will go to one of these places. Okay. Now look at this instruction. It says compare RO0x0. Okay. So let's assume, so my device is already jailbroken. I know that. Okay. So assuming it goes to the right, let's just assume. Okay. Actually it goes here if it's, I don't know the instruction BEQ, but I think it goes here. Okay. Doesn't matter. So I want the logic to be reversed. So if it's saying is jailbroken, I want it to show is not jailbroken. So I just want to reverse the logic. I don't know, I don't care where it goes, whether it goes left or right. I just want to reverse the logic. So if I just replace 0x0 with 0x1, that replaces the logic. And then the next instruction, instead of checking for 0, it will check for 1. And it will go either to the left or the right, but it will go to an opposite direction. Okay. So, okay, again, let's look at this method again. Here you can find the actual disassembly for this code. And if you go down, you can see this instruction here. Okay, compare 0x0. Now in Hopper, you can modify this instruction. So let me just say modify assemble instruction, and instead of this instruction, I'll write compare R0 to 0x1. Okay. So now this logic is reversed. Okay. Now I'm going to create a new executable using this. I'm going to call it modified, and I'm going to save it. Okay. Now this is my new binary, which is the patched one. So now I just have the binary, but I also need to create the entire IPA file. Okay. How do I do that? You can basically take a previous IPA file and decrypt it. Okay. Now how do you decrypt it? You just replace the .ipa with .zip. Okay. Use .zip and decompress it. It will create this payload folder inside which you can see all the contents. Okay. So now what I just need to do is that I just need to replace this binary with my original binary, and that's all, because this is the binary that actually contains all the code. Okay. So I think the name of my application was this, my binary was this. Okay. So I'll replace this binary with my binary. Oh no, not this. I'll remove this one. Okay, it's not needed, and I'll rename it to the original binary. So now this is my bundle. Okay, this thing is my bundle. Now I need to recreate this IPA file from this payload folder. Okay, but first, very important thing, I need to sign this binary. Okay, so I'm going to go to this particular binary folder, payload. Okay, and now I will sign this binary. So I'll say ldid-s DAM vulnerable iOS app. So now this binary is signed, it could be deployed. Okay, to create a binary from this payload folder, you compress this folder first, so it will become payload.zip, and then you replace this entire name with the name of the application. So the name of the application will be RAM vulnerable iOS app.ipa. Say mod.ipa. Okay. Okay. So this is my modified binary. Now I need to upload this binary onto my device. So, but first I need to uninstall my original binary. So I'll remove this. Okay. And now I need to copy this file to my binary, to my device. So scp my -r vulnerable iOS app modi.ipa to root at localhost. Uh, 172.62. So this is my device IP, and I'm going to copy it to the root folder. Okay. Yes. So this will start the copy of the new IPA file to my device. Okay. Uh, and now once I'm okay. So still copying. Almost done. Now how do you install IPA files using command line? There's a very important utility named installer IPA console. You can download it from Cydia, and it can let you install IPA files that are self-signed onto your device. Okay. So now I'm connected to my system. I can use install IPA. Okay. I can give the application name .ipa. Okay. Uh, Over here, as soon as I press this, you can see that this application will appear here. So let me press enter, and you can see it will come here in a few seconds. Oh, it did not come here, but it came here. Okay. So this is the patched binary now, which is deployed. If I did not sign it properly, it will crash whenever I open it. So it says trust. Okay. I'll trust him. So it's now working because I signed it. Usually if it crashes here, it means you did not sign it properly. Okay. So now, as you remember, we patched 3 methods, actually just one method, which was showing an alert for a jailbreak. So now, before, if I tap on jailbreak test 1, it used to show device is jailbroken. If I tap it now, it will show device is not jailbroken, because this method, this alert method is patched to say always this, no matter what happens. No, it actually reverses the logic. So now my device is jailbroken, it will reverse the logic and say device is not jailbroken. Okay. Even for this, it will show device is not jailbroken. And even if you go here, it will show device is not jailbroken. So I have patched, I did not patch the logic for jailbreak, I just patched this alert method, which shows device is not jailbroken by reversing the logic. If you run this on a normal device, this application, it will show device is jailbroken. It will show the reverse of what I did. Okay. To actually be able to perform good binary patching, you need to be assembly ninja, and that's a completely different course in itself. But I just wanted to show you how you can download an application, reverse engineer it, modify the assembly, sign the application, and then deploy it back and run the application. Okay, so this was the demo of Hopper. This feature of Hopper is only available in the, unfortunately, in the free version, in the enterprise, the commercial version. But you can reverse engineer methods. You can see the flow graphs, everything. You can see the assembly in the free version as well. So I would definitely recommend check Hopper out. Uh, so now these slides just talk about patching iOS applications, something that we just saw. Okay, I have written, and then you can. This is a different method of installing the same application, but this is a different technique in the slides. I have written a blog series on iOS pen testing that I would recommend you check it out. So if you go to this learn section, you have like 43 articles. Okay, starts with the very basics of iOS pen testing, very basics. Starts with setting up mobile pen testing platform, and I have written very detailed articles on patching iOS applications with Hopper using like this one. So it shows you how to patch iOS applications. The internet is not working, but it's also there on my blog. Again, so internet is not working, but my blog is highaltitudehacks.com. You can go here to read all the articles from scratch. You can also download this application for free to test your iOS pen testing skills, and you can also get the solutions for free. So everything is there for free. Uh, so now extracting device backups. Igor will take you from here to the very end. So if you have any questions for me, you can ask now. Anyone has any questions? So he will take you to the very end. Okay, he will show you some automated tools that you can use to perform some automation, because right now we've been using command line tools mainly for everything. So he will show you some tools that you can use to automate some of their tasks. But it's always good to start with your own command line tools from the very start. Thank you.
Для того, чтобы получить вообще доступ к устройству, что-то сделать с данными, вытащить оттуда, вообще не обязательно иметь постоянный физический доступ к этому устройству. В принципе, достаточно будет всего пары минут, чтобы снять полный бэкап. Есть два способа получения бэкапов. Первый – это локальный, как раз таки при наличии физического доступа, и второй – при помощи вытаскивания бэкапов из iCloud. То есть, как делается локальный бэкап? В этом помогает библиотека, точнее набор утилит, либо iMobile Device. Она доступна на GitHub. То есть сначала запускаем команду iDevice.id, чтобы получить список подключенных устройств, и затем iDevice Backup, чтобы сделать полный бэкап устройства по его ED-ID. То есть делается это буквально 2-3 минуты. Иногда вручную просматривать эти бэкапы неудобно, и есть разные утилиты, которые это упрощают. К примеру, вот iBackupBot. Все, что нужно, загрузить сюда файлы бэкапа, и он позволяет нам просматривать вообще всю файловую структуру бэкапа. Посмотреть все приложения, все их песочницы, все документы, которые там есть. Как тоже от этого уберечься? Во-первых, это может сделать сам разработчик, во-вторых, пользователь. Разработчик может помечать любые файлы, создаваемые в приложении, специальным флажком, который показывает, нужно их включать в бэкап или не нужно. То есть, допустим, если мы делаем какое-нибудь email-приложение, мы можем не захотеть, чтобы база данных с письмами вообще попадала в бэкап. Ну, нехорошо это. Спокойно ставим флажок, и все будет хорошо. Ну и что может сделать пользователь? В настройках iOS есть галочка, что все создаваемые бэкапы нужно шифровать паролем. Ну, на самом деле не панацея, все это брутфорсится, но тем не менее. И, как я уже говорил, еще один способ получения бэкапов из iCloud. Тоже в настройках iOS настраивается залитие бэкапа в iCloud напрямую, без участия компьютера. Все, что нужно, чтобы извлечь эти бэкапы, это Apple ID пользователя и пароль. Вводим в утилиту iLoot и на выходе получаем полный бэкап. Итак, много задач, много рутинных задач при подтестинге iOS-приложений могут быть порешены различным набором утилит для автоматического подтестинга. Сейчас пробежимся по их небольшому списку. Первое – это Snoopet. Сразу хочу сказать, что она уже не особо актуальна, поскольку поддерживает только 32-битные устройства под управлением iOS 7. Тем не менее, на самом деле софт хороший был, может быть еще обновиться. То есть что она позволяет? Стандартные вещи, как доступ к файловой системе, к кейчейну, к выводу NS-лога, позволяет просматривать список URL-схем. И кроме этого, такие интересные вещи, как подменить текущую локацию, подменить какие-то ID-шники, там MAC, адрес или UDID устройства. Вот так выглядит веб-интерфейс. Все довольно просто. Следующая утилита – это iAnalyzer. Она занимается статическим анализом нашего приложения. То есть из анализа всех классов, которые у нас есть в приложении, она строит, во-первых, такую удобную диаграмму связей, и, во-вторых, индекс по всем классам. То есть очень сильно помогает вообще при анализе приложения, чтобы понять, что, где, как происходит. iRed делает все практически то же самое, что и Snoopet, но обновлена под текущие условия, и помимо этого предоставляет одну очень интересную плюшку. Мы можем на лету писать и подключать к приложению различные твики, написанные с помощью системы Teos. То есть прям такая интересная вещь. И IDB, наверное, на данный момент самая популярная и используемая утилита для пентестинга. Не буду рассказывать, лучше покажу. По-моему, даже запущено. Подключаться к вот так выглядит главное окно. К устройству можно подключиться как по Wi-Fi, так и через USB. Вот сейчас я подключился к своему iPad. Посмотрим статус. Здесь перечислены все утилиты, которые должны быть в SID установлены. Теперь выберем приложение, которое мы хотим проанализировать. Сейчас он обновит весь список. Довольно долгий процесс. Написано, кстати, на Ruby. Можно в исходниках полазить. Что есть на этом экране? Здесь такие общие детали о приложении, к примеру, bundle ID, название, ED-ID, какие URL-схемы используются в приложении, там требуемая версия iOS и путь к директории файлов. Отсюда же мы можем либо сразу запустить это приложение на устройстве, либо залезть в папку с его данными. Вот сейчас еще анализ бинарника закончится. Пока давайте включу. Да, довольно долго. Да нет, тут он одно и то же смотрит. Вот он почему-то бинарник найти не может. Да, кстати, все, что происходит в IDB, выводится сразу в консольку. То есть здесь можно посмотреть весь лог. Вот он проверял, какие утилиты у нас установлены, apt-get, open, open URL. Вот, вытащил инфо-плейлист из директории приложения, оттуда вытащил всякие данные, там, к примеру, требуемая версия iOS. Иконку подгрузил. И вот теперь не может найти бинарник, к сожалению. Давайте тогда перезапустим и обойдемся без этого. Устанавливается, кстати, IDB достаточно геморройно, то есть там требуется определенная версия Ruby под самой последняя, почему-то не бегает, и куча зависимостей тянет, но где-нибудь, думаю, так минут за 20, за 30, в принципе, поставить можно. Так, эту вкладку посмотрели. Что у нас происходит на следующей? Вкладка Storage. Здесь мы можем посмотреть все плейлисты, присутствующие в приложении. Но сегодня не мой день. О, вот здесь можно посмотреть все плейлисты, которые есть. К примеру, ну вот, файлик с user defaults. Можно сразу отсюда открыть. Вот в Xcode его открыли. Здесь всякие такие настройки нашего приложения. Также на этой вкладке можно посмотреть весь список баз данных. И следующая вкладка – это URL-схемы. То есть, напоминаю, что вот здесь он уже на основной вкладке написал, что есть URL-схема DVIA. Здесь мы можем потестить, запустить с ней приложение, скормить определенный input, и даже есть вот такой вот фазинг URL-схем. На вкладке с бинарником, ну, сейчас она серая, задисейбленная, потому что у нас, как вы помните, ничего не проанализировалось. Но там можно, допустим, посмотреть output, то есть все строчки, которые есть в приложении. Это сигнатуры методов, захардкоженные ключики и много чего другого. Файловость, вкладка с файловой системой позволяет нам побегать по бандлу и по песочнице с Documents. Ну, в общем, все это можно. Tools, инструменты есть, допустим, чтобы вытащить снапшоты, которые делают приложения, о которых я уже рассказывал. Можно сразу здесь подсунуть сертификат, чтобы слушать HTTPS трафик, и вот даже редактировать файл hosts. Ну, вкладка с логом позволяет читать все логи, как и в Xcode, только здесь еще и такая чудесная подсветка есть. На вкладке Keychain можно сдампить все данные кейчейна, как уже сегодня делали в консольке. И на вкладке Pasteboard можно поработать с буфером обмена, посмотреть, что там есть, подменить эти данные, то есть запихнуть туда что угодно. Ну, на самом деле она обычно не так сильно лагает. И следующая утилита – это iSpy. Самая молодая из всех, на самом деле в ней еще практически ничего не работает. Есть вот только эта чудесная менюшка сбоку, информация о приложении и одна просто супер крутая штука, прям крышесносящая. Сейчас покажу. Ну, если заработает. Заходим в настройки. iSpy. Ставим галочку, что мы хотим инжектить его в приложение. И... О как. И проверяем, что инжектится в DVIA. Так, перезапустим. И вот сверху такая штука появилась, iSpy Loaded. Так, теперь мне нужен IP-шник. Ну, что у нас сейчас случилось? Сейчас внутри запустился HTTP-сервер, к которому мы, в принципе, можем подключиться и поиграться с iSpy. есть, видимо, проблемы с Wi-Fi. О, все. Нужно было открыть. В общем, сразу расскажу, если мы так не сможем загрузить, чем она такая классная. Вы помните, мы в консоли немного поигрались с iCrypt. Вот iSpy, дает нам возможность использовать iCrypt прямо вот с этой веб-странички. То есть у нас здесь просто откроется маленькая консолька, и можно ничем не заморачиваться, не искать айдишники процесса, подключаться, что-то делать. Мы прям сразу здесь открываем iCrypt, а вот уже все готово. Вот эта консоль. И давайте вот проверим. Так.
Вот там есть пункт для ASLR Wi-Fi подключения. Он работает?
По-моему, здесь еще не работает. Ну, ее буквально недавно начали делать, они вот все силы сначала бросили на то, чтобы вот реализовать такую консольку. Ну, вот, к примеру, получим объект Application и там, не знаю, и его делегат. Ну, вот, как видим, выдает нам адреса инстансов этих объектов, все хорошо, все прекрасно, все работает. Ну, на самом деле, как я уже сказал, iSpy имеет смысл использовать только ради вот этой консольки. То есть пока что там еще мало что есть. Ну, собственно, на этом мы заканчиваем. Можете скачать, как уже говорил Пратик, приложение Then Vulnerable iOS Application. Здесь куча челленджей, больше 40. То есть со всеми можно поиграться, попользоваться, потестить. То есть много чего интересного. Ну и тоже готов, если что, ответить на какие-нибудь вопросы. Всем спасибо тогда, что пришли послушать.